If you want heavy processing power in a portable machine, you pay for it in heat and battery life. For years, consumers have faced a rigid choice. You buy a thin, efficient laptop that lasts 14 hours, but struggles with basic video editing, or you buy a thick, heavy workstation to get desktop tier graphics, keeping you tethered to a wall outlet. NVIDIA claims to have bypassed this limitation with the RTX Spark Superchip. Their spec sheet promises 128 gigabytes of RAM and an RTX 5070 graphics processor inside a slim chassis, while still maintaining all-day battery life. Achieving these specs required NVIDIA to physically redesign the internal communication between components from the ground up. This standard motherboard layout shows the CPU, GPU, and memory as distinct islands, separated by inches of circuit board. Processing high-end video requires pushing massive volumes of data across these pathways. This physical travel time creates an architectural traffic jam. Forcing electricity across these physical gaps to constantly shuffle data between chips is the primary cause of battery drain and the excessive heat that triggers loud cooling fans. The engineering fix for this fragmentation is called a system on a chip, or SoC. This design framework places every vital processor onto one single piece of silicon to eliminate the distance between them. To eliminate the bottleneck, NVIDIA had to figure out a way to compress desktop-size processing engines down to a microscopic scale. NVIDIA partnered with MediaTek to manufacture the Spark using a 3-nanometer process. By etching electrical pathways at a nearly atomic scale, they reduced the physical space required for the circuits, which lowers the power required to run them. This bare silicon wafer illustrates the new design's density. First, a 20-core Grace CPU drops in to handle heavy computational logic. Next, the Blackwell GPU, loaded with 6,144 CUDA cores for visual rendering, locks right beside it on the exact same wafer. Because these two engines sit mere millimeters apart, the transit energy for data drops to near zero, resulting in massive battery savings. The hardware density is a major step, but the mechanism that allows the laptop to maintain high performance is its 128 gigabytes of unified memory. In the fragmented motherboard layout we looked at earlier, CPUs and GPUs manage their own separate memory banks. If the CPU updates a file, it must copy and send that data over to the GPU's memory bank before the graphics card can use it. Look at how this diagram visualizes unified memory. Instead of copying and mailing files back and forth, both the Grace CPU and the Blackwell GPU have direct access to the exact same central pool of data at the exact same time. Removing that transfer lag lets the RTX Spark process information fast enough to run large language models entirely on the device, offline, without waiting for a cloud server. NVIDIA also built an enterprise variant called the DGX Spark. It uses this same central memory pool to handle massive local code compiling and heavy office multitasking without stuttering. By giving both processors instant access to one massive memory bank on a microscopic chip, the laptop delivers desktop-tier AI and graphics while pulling a fraction of the electricity. This architecture turns the laptop into an independent, localized data center that no longer depends on the cloud for AI tasks. It processes complex information right on your desk without needing an external network. Consolidating these parts into a single superchip is an aggressive move by NVIDIA to capture territory in the mobile hardware market. Historically, companies like Intel and AMD have relied on architectures where the processor and memory are distinct units, which limits how efficient a slim device can be. By proving that a single integrated chip can match desktop performance, NVIDIA is challenging the technical standards that have kept those companies in power for decades. With local AI processing and heavy graphics now running smoothly without draining the battery, is it finally time to leave Intel and AMD behind? Let me know in the comments. The era of the compromised laptop has ended. With the superchip architecture eliminating physical bottlenecks, high-performance portable computing has a new standard. Subscribe to TechPulse Daily for more hardware breakdowns, and I'll see you in the next video.